What if an agent breaks every assumption you brought with you? And the failure mode is not a bad response. It is your customer data leaving the building. An AI agent is not a stateless function. It is a long-running process with a shell, a file system, and untrusted input pointed at it. So deployment is a question of architecture and isolation, not just where you host the function. In this video, you will learn why an AI agent built on the Claude Agent SDK cannot be hosted like a stateless function, the 3 container lifecycle patterns that cover almost every real deployment, and a practical isolation ladder, from a 5-minute sandbox to a hardened container to per-agent microVMs. By the end, you will understand prompt injection as a deployment threat and the one architectural move, a proxy the agent cannot bypass, that makes it survivable.
Standard LLM features use a predictable architecture. A stateless request comes in, returns text, and closes. The Claude Agent SDK breaks this. Instead, the agent enters a loop, reading files, running tests, evaluating output, and retaining context every step. To perform this work, an agent requires a long-running process with a persistent shell and a real file system. This persistence changes your threat model. Standard software executes code paths you wrote, but an agent generates its own actions based on external content, like repositories and web pages, that you do not control. Because the agent is a live, networked process, a security breach allows it to package and export your customer data directly out of your infrastructure. Hosting these systems is a task of building rigid architectural boundaries and physical isolation. The physical footprint for a single Claude agent process requires Python 3.10 or Node 18, 1 GB of RAM, 5 GB of disk space, and 1 CPU. While the container costs roughly 5 cents an hour, the real expense lies in the model, the thousands of LLM tokens consumed as the agent iterates through a task. This continuous execution presents an operational risk. Agent sessions do not automatically time out. You must configure a hard max turns limit to prevent an agent from spinning in an error loop and exhausting your token budget. The safest deployment pattern is the ephemeral session. A fresh container spins up for a single task, like a bug investigation or a batch translation. Once the work is done, the container is completely deleted, providing inherent isolation. For high-frequency tasks where cold start latency is unacceptable, you use a persistent session. The container stays warm to handle a continuous stream of requests. This responsiveness requires manual management. Since the container is long-lived, your team is responsible for cleaning the state and file system between sessions to prevent cross-user data contamination. The hybrid session handles intermittent work. An ephemeral container spins up, retrieves history from an external database, performs the task, saves the state, and spins down. Your choice between ephemeral, persistent, or hybrid life cycles dictates how your system will handle memory, latency, and isolation boundaries. Securing the agent requires addressing its dynamic execution. Unlike traditional software, an agent determines its next steps by analyzing the content it encounters in the workspace. This leads to prompt injection. If an agent reads a malicious README that contains hidden instructions to exfiltrate environment variables, the agent may treat those instructions as its new objective. While models are trained to resist these instructions, relying on the model's internal guardrails is an insufficient security strategy. You need multiple layers of external control. Level 1 of the isolation ladder is the sandbox runtime. It uses OS-level namespaces, like bubble wrap, to enforce file system restrictions with minimal setup, ideal for single developer environments and CI/CD pipelines. However, because it shares the host kernel, it remains vulnerable to kernel-level escapes. It is not designed for multi-tenant systems processing untrusted input. Production environments require Level 2, the hardened container. You must strip Linux capabilities, block privilege escalation, and set the root file system to read-only. You also need to cap resources. By setting a strict limit on process IDs, you ensure a compromised agent cannot launch a fork bomb to exhaust the host's resources. These protections fail if you mount sensitive host directories for convenience. Mapping your SSH or AWS credentials into the workspace provides an injected agent with authenticated access to your core systems, bypassing your other security layers. Because prompt injection is a structural reality of agentic workflows, a hardened, restricted container is the minimum requirement for handling user data. Even a hardened container shares the host kernel. When processing genuinely untrusted or multi-tenant input, you must create a more significant boundary. Level 3 isolation uses gvisor, which intercepts system calls in user space. This creates a barrier that prevents malicious code from interacting directly with the host kernel. For the most sensitive workloads, Firecracker microVMs provide every agent with its own dedicated hardware kernel, achieving near total isolation from the host. These tiers introduce a performance trade-off. While CPU tasks remain fast, the extra layer of interception can slow down file I/O operations significantly. The most effective security move at any level of isolation is to strip the network interface from the container entirely using the network none flag. To maintain necessary communication, you use an unbypassable proxy. The agent communicates only through a mounted Unix socket to a proxy server running outside the isolated environment. This external proxy manages the authentication tokens. It enforces a strict allow list of domains and injects credentials only for authorized requests. The agent itself never touches the sensitive credentials. Implementation can be simplified using cloud-native tools like Envoy for credential injection, or by using managed sandbox providers that offer this architecture as a standard feature. This proxy-based architecture makes prompt injection survivable. If a compromised agent has no physical network path to an arbitrary server, it cannot exfiltrate your data. Deploying an agent requires moving past the stateless API mindset. You are managing a long-running process that has direct access to a shell and a file system. Success depends on 3 non-negotiables: choosing the correct lifecycle, mandating a max turns limit, and building the architecture under the assumption that the agent will encounter compromised input. Use defense in depth. Isolate the file system, strip privileges, exclude secrets from the workspace, and route all network traffic through a hardened proxy the agent cannot bypass. Follow us on LinkedIn and subscribe to our Substack and Medium channels for technical deep dives. If you are ready to secure and scale your enterprise AI agent architectures, contact Spillwave today.
About the author, Rick Hightower, Claude Certified Architect. Rick Hightower helps companies become AI first through practical mentoring, executive and team training, and custom AI solution development. He is a former senior distinguished engineer at a Fortune 100 company, where he focused on bringing ML and AI insights into real frontline business applications. Rick is a Claude Certified Architect, AI systems practitioner, and builder of production multi-agent systems. He is currently working on authoring a book on harness engineering with Manning Publishing. He created Skills, a universal agent skill installer supporting 30-plus coding agents, including Claude Code, Gemini, Copilot, and Cursor, and co-founded one of the largest agentic skill marketplaces. Today, Rick and the Spillwave team works with leaders and teams who want to move beyond AI experiments and build real AI capability inside their companies. He helps organizations adopt AI safely, train their people, redesign workflows, and build practical AI systems that create measurable business value. Ready to make your company AI first? Connect with Rick with the links in the video description. LinkedIn, Substack, or Medium, book him to speak or train your team, or visit Spillwave to explore mentoring, training, and custom AI solutions for your organization.